So, you guys just took your online learning target thingamajabber, right? And you all told me certain characteristics we know about solids and liquids. So today we're going to focus on information we can learn and better understand about gases. Okay? Because gases are hard to observe. What makes gases difficult to observe? Adrian.
Because there are ones in here.
Okay. What else?
You can't see them.
Mm.
You can't see it or touch it?
Okay, so we struggle. In fact, I think when we were doing the tube activity, someone said, well, how do you know that gas exists, right? We talked about that. We said, how do you know gas exists? Because, don't worry about it, smoking is normal. How do you know that gas exists? Because you can't just directly observe it, but we can. So we're going to talk about ways that we can observe it today. I have to put on my nifty glasses. All right, because safety is important. So what I'm doing here is you guys saw me pour some water into this can, right? Oh, it's just snow. Okay, so you saw me pour some water into this can, and if I shake it here, you could hear that there's just a little bit of water. So what I'm doing is I'm actually trying to heat the water inside that can. And I'm heating the water inside the can to the point that it becomes a gas, right? Okay? And we'll talk more about what that means in a little bit. But we have to wait till that is fully heated. So tell me some of the things that you know about solids and liquids.
Mrs. Spohr and Seth Brown, please come to the office. Mrs. Spohr and Seth Brown, please come to the office.
Liquids can take any shape or form
Any shape or form of what?
of a container.
Okay, what else do we know? Yes.
They fill the container from the bottom to the top.
Okay.
It's full of solids.
So when I pour this, right, this flows, and if I was pouring a solid, it just plops, right? Okay, be careful because some of you guys tried to say that all solids are hard, but we used an example of solids not being hard yesterday. What was that? Yes.
Powder?
Baby powder and
Clothes.
what?
Clothes.
Or clothes, this balloon, a marshmallow, unless you left it out too long. Gross. Okay? We get this boiling yet. No, we don't have it boiling yet. Okay, so what you guys need to do anytime we're doing demonstrations like this, you have to have your notepad out. I'm horrible at staying in one place. That's why recording is awful for me. You guys need to have your notes out, and I want you guys to make predictions. And then I'm going to have you make observations. The predictions and observations are entirely your own, okay? They should be entirely your own. So as we're heating this up, this is what I want you guys to do. In a second, I'm going to take this very hot can, right, that I heated the water inside to the point that it's become a gas. And I'm going to flip this can into this pretty cold water. And that action is going to force all of the gas out of the can. So I want you guys to draw a picture of what the can's going to look like. Is it going to change? Isn't it going to change? These are your thoughts. You're making a prediction. Draw what you think might happen as I force that gas out of the can. Okay? You guys should be drawing. You just what you think. It's a prediction. What might happen to the can or what might happen to the water?
Yes. Hot water and cold water.
All right, so you guys should have drawn in your notes what you think is going to happen. And I'm going to ask a couple of you guys to put your drawings on the board. Go ahead and throw your drawing on the board. Superintendent, put your drawing on the board. Thank you.
I forgot to give you attendance. Yeah, I have Dallas missing. Yep, not Dallas line, Dallas in. Yep, thanks.
Can you draw what you have? Draw it on the board. Okay. All right, I think I've represented what everyone thinks might happen. Please be careful around that. Because, you know, it's hot. I'm the only one wearing the safety goggles, so.
Colton, where is that? Where is that?
All right, so quickly drawing what you think is going to happen. And then I'll ask you guys to describe. And this is a pretty accurate representative sample of all of your guys' ideas. Hey, Judgy? It's okay. Be very chill. Okay. All right. So, who drew this one? Drive. What? What's gonna happen?
I think when the Americans steam out, like,
Okay. What do you think is gonna happen? All right. And what do you think is gonna happen, Amy?
it's gonna explode.
You think what's gonna explode?
The can.
The can is going to explode. Are we ready?
Yeah.
Okay. So, let me remind you what you're supposed to do is immediately take observations of what happens, right? Okay? But you're going to want to watch closely because it's going to happen the way you see it.
It's amazing.
I don't want you to miss it, right? Okay. Are you ready?
Yeah, I know.
Here we go.
I knew it!
All right.
Exploded.
So, now this didn't happen as good as an option does. So I want you to do it. They close pretty quick. The joys of aluminum. Okay, so draw what did happen. If I had gotten it better down in there, it'd look more like this. Draw what actually happened. When the gas left the can, what did you observe happen?
Direction.
When the gas left the can, what did you observe happen? Just do the best you can. All right, so tell me guys, what, and I need to hear from someone new because I don't like hearing from the same people. What happened? Mauricio.
I like got sucked in. Like,
Sucked in. Okay, what do we observe happened to the can?
It sort of crumpled and squished itself.
So, we know that liquids take the shape of its container. And we just observed that when gas left the container, what happened to the can?
it kind of like, it's kind of the same reaction like when you suck in all the air from a plastic water bottle and it like crinkles up.
Okay. So what can we say about a property of gas then, that we just observed? What happens? What can we say about a property of gas?
It fills the space in the can.
Okay, so I want you guys to write this down. First property of gas. Gas fills space of container. Now I'm going to say something kind of mind-blowing right now. If this room was not filled with gas, guess what would happen to this room?
It would explode.
Did this can explode?
Yes.
It imploded. It would collapse. If this room was not filled with gas, because the gas is pushing on the walls, it would do the same thing that happened to this can. Whoosh! Thank goodness, right? Okay, so matter has to fill the space. When we removed matter from this can, it collapsed, okay? So I want you guys to also write that. Matter takes up space and holds shape. All right. So yeah, matter takes up space and holds the shape of the container, just like we saw with the can, right? Takes up space. You guys said this. Gas fills the space of the container. All right. So, you guys ready to see me blow something on?
Yes.
No? Yes?
Yes.
Something up, please.
All right. Here we go.
Oh, great.
Yes.
I blew it up.
No, make some noise.
Here's what we got. Yeah. All right. So I've got this balloon here. I've got this lovely balloon here, and we are going to make some predictions. So I have this fancy thingamajobber over here by Billy. It's called a scale. Ooh, very nice. Thank you. All right. So I'm going to put this balloon, when it's not filled with anything, on the scale, right? Okay? And I want you guys to write down its mass. Mass is the amount of matter that something has. So we're going to write down its mass.
What else?
Can you tell everybody? 3.06. And then after I blow this bad boy up, which is so very impressive, I want you to predict what is going to happen to the mass inside this balloon. When I blow it up, what do you believe is going to happen to the mass inside this balloon? Write it down. Everyone should be writing. Should be quiet. What is going to happen to the mass inside this balloon when I blow it up? How many people said the mass will stay the same? Raise your hand. How many people said the mass will increase? How many people said the mass will decrease? How many people said just blow up the balloon and mass it, Mrs. Borton? Let's get on to something else. Oh, okay. Very good. Thanks. All right, here we go.
Stop it. Talking about full small. Not the whole. Don't kill it. Don't kill yourself.
All right. Gotta do better at time. Thank goodness I have my lovely assistant Billy standing by the scale. Here we go. All right. So we're ready to see what happens, right? We've just noticed that the first property of matter we already said is happening, right? Gas is expending to fill this container, right? It's filling it, okay? So we've already seen that property in this balloon. Let's see what happens next. So Billy, can you tell everyone the mass, please? Yeah, right there. 3.28. 3.28. So someone tell me, what happened? Manuel. The mass went up. This is an important property of matter that we always forget about gas, but guess what? Gas has mass. So if we add gas to the container, the mass has to increase because gas has mass.
Wait, what?
We just saw it, right? the mass went from 3.0, was it 6?
Yeah.
6 without gas, right? And then it increased to 3.28, right? With gas. So, most of us thought that either gas wasn't going to change the mass at all, or that adding gas would decrease mass, right? But I want to point you to the fact that we just observed that it increased, right? Okay, whose birthday is closest to today? Logan, what's your birthday? 26th.
13th.
13th. And today is?
The 18th.
19th. He's first. Mine's the 21st.
Oh, well, that's 2 days.
Yours is the 21st. Oh, there we go. Happy birthday to you! Happy balloon. Okay. All right. So I've got one more that I need to show you. So we've seen that gas fills up the space of the container. Okay. Doesn't necessarily fill from bottom to top. That is how it's different from liquid. Okay. And we also know, and this one's really important, if you need to underline it in your notes, gas has mass. It's not weightless. Gas has mass. It's matter. Matter is a measurement of how much mass stuff has. Of course, gas has mass, right? Okay, because gas is matter. Okay, so here is our last property. And to do this one, I need that table completely cleared off and no students on it.
She wants some help. Ella wants some help.
All right, so over here, I've got these ancient relics. Anyone know what these bad boys are?
No, battery.
It's an ancient relic.
It's called a Catholic.
Something.
More specific than that.
Something. A tube. It's a
It's a film canister, because back in the day, you know, you had to store your film in here so it wouldn't get exposed to light. And yeah, we don't do that anymore because we don't really use film, right? Okay, but this is a film canister. Really thankful that we have them because they're cool. All right, and then what I have is these things called effervescent tablets. Now, what we're going to observe in a second is what's called a three-state reaction. So I want you to look at the water, and you'll notice. I'm going to grab this water. And you guys will notice something. So I want you guys just to quick jot down your observations after I drop this tablet into the water. Just write it down. What are we noticing? Just write it down. Quickly, what are you noticing? What's happening? Writing it down. Okay, so what do we observe happen? Taylor.
It's like fizzing up and
Fizzing up. Okay, so what state of matter is this?
solid.
So how do we know? Logan. Holding its shape, right? One property of matter. Solids keep their shape. What state of matter was the stuff in this container? How do we know? Ella. Took the shape of its container, okay. And so then, when I dropped it in there, what state was created?
Yes.
How do we know?
Because
Yeah?
there's like all kinds of little air pockets and stuff like that.
We can see the bubbles, okay? We can see lots of bubbles. Okay. All right, so what I'm going to do here in a second is I'm going to take one of these tablets and I'm going to put it inside the container with some water. And I want you guys to write down what you think is going to happen. Should be quiet. What do you think is going to happen? Write it down. it down? Finish right in there. Check on my people in the hallway. Okay.
Josie, I'll pop that one.
All right. Are we ready?
Can I keep the pill in there?
All right. So here we go. I'm gonna drop this effervescent tablet in there. I'm gonna throw the cap on. Give it a good shake because you know that's fun. And then I'm gonna tip it over. Okay? And we're gonna observe what happens. Are you ready?
Yeah.
Yeah. Okay.
There's a bomb. There's a bomb. Shake it up.
Okay. So.
Oh no, no, no.
See. That cap's not holding very well.
We all don't need to see.
All right. You gotta find a better cap.
Take two.
Can I do take two? So cheerful.
It used to be that I had exactly my favorite containers, you know, because you find your favorite ones and you name them and then you love them.
Why would you name it?
Because you name the things that you love, right? But then I moved classrooms, so then I don't know where my ones that I loved were. So we'll try it again, because that was anticlimactic. What do I mean by anticlimactic? Yeah, it really wasn't. Okay,
Let's do it again.
here we go. We'll try it one more time. Hopefully. Hey, this one's cool because you can like see it.
Oh, we can.
All right. So let's see.
Come on, explode.
What happened? Write it down. Write down what happened. Quickly, write it down. What happened?
Oh, that was funny. That was fun. Would it hurt?
Because I want you guys to think about what does this mean about gas? What happened? Okay. So first, someone I have not heard from yet. Tell me what happened. Margaret.
The bottom got popped off because of air pressure.
Let's talk a little bit more about that. What do you mean air pressure? Why did it shoot off like that? Lindsay.
Because the gas was slowly coming out, and once enough came out, it went in, and then it shot off.
Okay. Was the gas coming out? What would build pressure? Remember what we said pressure was yesterday? Pushing, right? Okay. So if we are building pushing on the container, what eventually happened to that gas?
It got out of the container.
Okay. Carter, what do you got?
It filled the area of the container so much that it exploded.
Can you say that louder?
It filled the area of the container so much.
So here's something you guys need to know about gas, and this is another important one. Are you ready? Gas likes to take up as much space as possible. Gas likes to take up as much space as possible. So like Carter was saying, right? It's trying to take up space. And this is what happened. The gas said, I want to take up space, I want to take up space, I want to take up space, I want to take up space! Right? And it didn't have any space because more gas was getting created, it was getting shoved together, and it said, I'm out of here, right? Because as soon as it got out of the container, that gas could spread out again and it could take up more space. So, just like we observed with the container, gas likes to take up as much space as possible. Now I'm going to do it one more time. Yay! Hopefully,
I have a question.
can you turn that for me?
Billy's the cameraman.
So this time I'm gonna do two different things. And I want you guys to make predictions. Listening. Listening. Okay, so the first container I'm gonna put a whole lot of water in. And the second container I'm gonna put just a little water in. Okay. And I'm gonna put the same amount of tablet. I want you guys to write down in your notes which one do you predict is going to go higher. Not right now. Which one do you predict is going to go higher? We got to do this quick because the bell's about to ring. Are you ready?
Yeah.
Okay. Okay.
One.
Are you ready?
1, 2, 3, 2. Put the capsule on. Shake it up. Shake it up. Shake it up.
Time out. Which one went higher? The one with just the time out, guys. I don't care if the bell rang. I dismiss you, right? So the white one went higher. The white one had less water. The reason that the white one went higher is it had more space for that gas to build up pressure. So it was just gone. Okay? All right, guys. I was attacked by a lot. I need that bottle.